Well, hello and welcome to this first informational video from Cali Mark. That's going to be my new moniker. Hopefully people get to know me by, but Cali Mark UK. My name is Mark Taylor and I'm a biochemistry teacher of 25 years and am now entered this industry and would like to start speaking a little bit today and teaching some people about some very simple but common growth techniques and how you can increase the growth in your plants. Today I'm specifically focusing on the fact that we have three things that we call in this industry aerators. Okay, and we tend to put those three things in either two types of media, either cocoa or peat. Some people will say soil. But the fact is, these three different types of aerators, they work differently, and some work better than others. So let's start. I'm going to show you. I put a tray here to demonstrate. The first one a lot of people are real familiar with is perlite. And perlite I'm going to hold here. It's very light, not very dense. A lot of people don't realize that perlite, when it's mined from the ground, is a dense rock. It's heated up to about 1,000 degrees where it pops open. And you can watch this on a YouTube video, but this stuff pops open and becomes very light and not very dense. It also crushes into powder really easily. Now, the benefit of perlite is significant. The benefit is that perlite is an insulator. So perlite keeps the temperature regulation throughout your soil nice and even. But the one thing you won't ever see is you'll never see roots actually wrapping around that perlite, because roots don't specifically wrap around the perlite because there's not a lot of bacterial growth on it. So then I moved to the next two media, and the first one that people are commonly used to seeing, and one that came out in the market over 30 years ago, are clay pebbles. Now keep in mind that clay pebbles are man-made, and I asked the question, what on this planet in nature is perfectly round like clay pebbles, or even slightly rounded like clay pebbles? And since I can't get an answer from all of you, I'll answer it myself, but nothing except pebbles at the sea, and maybe pebbles or rocks in a river, but things that have been turned by water that then turn around. But in nature, there is nothing perfectly round like that. So actually, when these were developed and they are man-made, they're not the most beneficial really for a plant, because what it does aerate and make space in the soil. But as you're going to see later, it doesn't have any kind of the benefits that lava rock does as far as having the surface area for bacteria to grow. And we're going to get to why bacteria is so beneficial in just a second. So before I do get to that, I want to do a quick little demonstration to explain something that we've most all had sometime in science, maybe back in GCSE science, but maybe have forgotten. And that's the lesson of surface area. So I take two pieces here of paper that I have, crepe paper. They were both the same size starting out, but one of them I bundled up hard, and we can see that one. Obviously I drop it, it falls like this. And then if I leave one open like this, so the same size piece, we notice that if I just drop this, it's going to almost float in the air, right? And that's because it acts just like a parachute does, because it has more surface area. Right? Surface area is something we talk about a lot in science, and surface area is very important for the growth of living things. Our brains are convoluted with wrinkles to give it more surface area. Our intestines have lots of bends and folds to give it more surface area. And we're going to see that the part that in our industry I think has been not explained to growers is what the benefit is of aeration itself. So I'll ask now and I'll pause, why do we aerate soil or cocoa? And when I ask that question, and I've traveled now 11,000 miles in England, 99% of the time I'm told to get oxygen from the plant. And people forget their general GCSE science, that plants do not need oxygen, they produce oxygen. So that's incorrect. We're not aerating to actually get oxygen to the plant. What you're breathing right now, what I'm breathing, is 79% nitrogen. And nitrogen is the king of all the elements that plants need for probably their single most important nutrient. Because anything solid in a human body or in a plant, anything solid that you can feel, has to have nitrogen in it. Okay? So plants need as much nitrogen as possible. If we could absorb the nitrogen that's in the atmosphere right now, we'd be about 20 feet tall. We'd be huge. We wouldn't have to eat protein. But plants, they're not going to digest protein the same way. So the reason why we actually want air getting into the soil is to get that 79% nitrogen to the plants. And then the last piece of the puzzle is this. So how does that nitrogen, how do plants get that nitrogen from here, the atmosphere and the air, how do they get it inside themselves, right, to build, to make that structure? And the simple answer, a lot of people would like to say, is that it's just absorbed in the soil. It's not quite that simple. It's absorbed, but it's absorbed by what we call nitrogen-fixing bacteria. And those bacteria, they absorb the nitrogen out of the air, and then they surround the roots in the soil, and they're able to take that nitrogen, and it's absorbed right back in from the bacteria into the roots. So we go back to this. I'm going to take a little bit larger piece of lava rock to demonstrate this time. If you take pieces of lava rock and you compare them to pebbles, which one quite obviously has more surface area for bacteria to be growing on? So lava rock, because of all the little tiny openings and crevices, has about 25 times more surface area for bacteria to grow on. And if that happens, what happens is, I'm going to now turn to my handy plasticine model that I made earlier to show you. Let's say, for example, this is a piece of lava rock. On that lava rock, all these little green dots represent nitrogen-fixing bacteria. So the more bacteria you have on there, the more nitrogen is going to be absorbed by the plant. And I would say, again, try this as an experiment. That's what science is about. Don't change your whole crop all at once, but take 2, 3, 4, 5 plants and try the difference between a media that has clay pebbles in it versus a media that has lava rock. And you will see consistently every single time you're going to have greater growth and more yield by using lava rock in your media. Okay, so this is the first of an educational video that I'd like to continue on with. But I would like to say, again, try it yourself. The proof is in the pudding, but this is science. This isn't sales. This isn't some gimmick. It's about how plants grow. And to finish off, we'll just say that genetics are millions of years old. And plants' genetics have not actually developed to have round clay pebbles in the root system, but they have with lava rock. And you'll see the difference. So thank you for your time.